So the test was worth 18 checks, 9 on the multiple choice, 9 on the free response. I saw some interesting shadow puppets. Some of y'all are really fantastic artists. Oh yeah, they drew. Yeah, the most common answer was the dog, right? That's like the only one I know, right? Yeah, the dog. Some people even put classic dog, and perfect description, classic. Classic. So here we go. Multiple choice, show all work. So the first one, you have a product of two functions. It's an indefinite integral. So you're going to have to put plus c, and all the answer choices have plus c. Darn it, so you can't get rid of some of them. But if you rewrote it with the radical as a rational exponent, then that's kind of one of the first steps you could always do. There's no constant multiples pull out front, so hopefully you gravitate to 5x squared minus 4 to be the inside function. It is. Its derivative is 10x, which generates the x outside. So that's where that came from. But we're off by 10. So the x gets packaged back up, and we have a correction of 1/10. And then we move on to part 2, which is the rule of integration. Blob to the 1/2 becomes the same blob to the 3/2. And instead of dividing by 3/2, we multiply by 2/3, and we put plus c. And then all you have to do is simplify. 1/10 of 2/3 is 1/15. And I even left it in rational exponent format on the test. So now you just got to find that answer, and it's answer choice B. And there you go. I didn't even have an answer of just the 2/3 in the front if you had forgotten the correction. So anyway, I thought that was a nice, easy one to start with. I don't think as we go through here, of course, the goal is to realize why you missed it. Maybe you used the wrong method. Maybe you had no idea what you're doing. Maybe you just missed it by a negative or something. If you find that I counted something wrong and it should be right, let me know. I'll give you the points back. If I counted something right and it should be wrong, just keep your mouth shut. Okay? Even if you did bring it to my attention, I wouldn't take points away from you if I've given them to you already. So, all right. Part B, average value of a function. How do we find average value? Average value. Integral over width, integral over width, integral over width. Good. So the function is x minus 1 squared, and the interval is from 1 to 5. So in the spirit of trading for a free response, where notation matters, get in the habit of labeling your integrals. So average value equals the integral from 1 to 5 of x minus 1 squared all over 5 minus 1. This would get a check on a free response. And again, get in the habit of labeling your integrals. All right, so now to evaluate it. Well, first of all, the denominator becomes a 4, and dividing by 4 is the same as multiplying by 1/4. So I brought that out front. Then to evaluate the integral, x minus 1 squared, there's a couple ways to do it. If you just think of x minus 1 as being the inside function, inside blob squared, what's the derivative of x minus 1? 1. We have a 1 out there. We're not off by anything. So the 1/4 would go for the ride. There would be no correction to make, and it would just become a power rule. Blob squared becomes blob cubed divided by 3, 4 times the third, and then no plus c because it's a definite integral. So then we would evaluate it from 1 to 5. Now it's my personal preference, whenever I have coefficients, 1/4 times 1/3 is a 12th, I like to put them out front. I do not carry them through with each term. When I plug in the top minus plug in the bottom, I prefer to leave them out front, less to carry through each term. I also really enjoy drawing beefy brackets. It's fun. So that gives me an opportunity to do that. Right, Jonathan? Yeah, good. Okay. So then we plug in the top first. So 5 for x becomes 5 minus 1 cubed, minus plug in the bottom, 1 minus 1 cubed. Now on a free response, this line right here is a good stopping point. But of course, I didn't type that up as an answer. So we carefully simplify. Please excuse my dear Aunt Sally. Probably don't invite her to family reunions anymore. Always trying to make excuses for her. We get 4 cubed minus 0 cubed, which is 64 minus 0, which is 64 on the inside, times the 12th is 64/12, and that simplifies to 16/3. Okay, 32/6, then 16/3. However you get there, you get 16/3. So that's, I think, probably the easiest way to get to the answer. But there's another way to evaluate this indefinite integral. You could, because squared is a pretty modest little exponent, you could have expanded square multiply double square. And then you have x squared minus 2x plus 1. And now it's just power rule, power rule, power rule. A third x cubed minus x squared plus x. It does evaluate a little bit more scenically. Okay, and it's kind of worth just pointing out that when you plug in the top, I have my brackets with the 1/4, but parentheses when I plug in the top, and then minus, super important, parentheses when you plug in the bottom, because you're now subtracting multiple terms. I didn't actually do the math here. I cheated. I know it's supposed to be 16/3. I didn't feel like doing all that work without a calculator, but if that's the way you did it, it would come out to be 16/3. Okay, so again, a little more scenic. Maybe best saved to do it that way for like a Sunday afternoon. All right, any questions so far on either 1 or 2? All right, number 3. The dx was in the top, but I hope that didn't throw you off. Okay, you had the option of bringing it out front or just ignoring it. If you were to bring it into the top, the 9 plus x squared, you would write it like that. The derivative of 9 plus x squared is 2x. Do we have an x out in front as a helper factor? No. So if you're off by an x, maybe then you consider u substitution. Is 9 plus x squared a good candidate for u substitution? No, because 9 plus x squared is not linear, right? It's not linear. So u substitution won't work. So what else could it be? Well, if you're stuck, maybe look at your answer choices. That's what's nice about a multiple choice. And I feel bad that I put all of them in terms of inverse tangent, because that's kind of a giveaway then to what the antiderivative is. Okay, maybe next year I'll put a natural log choice there as well. If there were an x on the top, it would be a natural log. But in this case, it's an arctangent. So it's just a matter of identifying the u and the a. I flipped the sequence around. You don't have to. X squared plus 9, though, is the same as 9 plus x squared. So if u squared is x squared, then u must be x. And what's the derivative of x? 1. Is that what we have in the top? Yep. So that's good. Perfect. A squared is 9, so a is 3. So now we can go straight to the memorized pattern for arctangent. The rider is 1, so that's really nothing. There's no correction to make. So the question then remains is, do we have a 1 over a in front as part of the rule or not? Arctangent does. So it's 1 over 3, arctangent of u over a, which is x over 3. And if you look and look and look, you won't see any arctangent answers. So then you guess, right? No, arctangent is the same as inverse tangent. 1/3 inverse tangent, x thirds plus c. You'll never have an answer choice that's perfectly correct without a c and then perfectly correct with the c. They'll either all have plus c's or they won't. In this case, they all do. Sweet. Any questions on number 3? 3 for 3? If we were to have the same test tomorrow, at least you get 100 on the first 3. And not because you memorized the sequence to be B, B, B. Oh my gosh. If you got that on the test, you're like, he's not going to give us 3 B's in a row, is he? There's no way. B, 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 I did something wrong. That's like Better Business Bureau. That's the only time I've ever seen 3 B's in a row. You stuck with it. Good. Yeah, it's all random. All right, number 4. You have an inside function of x plus 3. Its derivative is 1, not x. We're not off just by a constant. There's an x out there. Is u substitution a good candidate for this one? Yes, we can expand, can distribute. X plus 3 is linear. It's x to the first. Linear function, off by an x or off by more than a constant factor. There it is, constant factor. Perfect situation for u sub. All right, so here we go. Here's the u sub. This is what it looks like. I rewrote the function up here, but I wrote it in radical format. The goal, remember, is to replace all your x's and dx's with u's. So let u equal x plus 3, and then the du dx is equal to 1. So if you multiply both sides by dx, you get du and dx being equivalent. And this was an easy one to solve for x. It's just u minus 3. So now we'll start replacing. And I did it from left to right here, color-coded it with blue. So x becomes the quantity u minus 3. X plus 3 to the 1/2 becomes u to the 1/2. That's in brown. It looks like red, but it's brown. And then in green, dx and du are the same. So there it is, written in terms of u. And what was the next step always after we replaced the variables? Distribute. Right, and now we can. Because now we have the monomial to the funky power of 1/2, not the binomial. So if we distribute and add exponents, we get u to the 3/2 minus 3u to the 1/2. Just a notational note here. We do have parentheses there to group the terms together. But now it's just a power rule, right? Simple power rule. So u to the 3 halves becomes u to the 5 halves, and a 2/5 out front. Minus 3 goes for the ride. 1/2 becomes 3 halves with the 2/3 out front, plus c. And then the last step is just to replace u with what u is. What is u? X plus 3. And then on the second term, of course, the 3 and the 2/3 combines to give you a 2. So I didn't even factor out least powers for my answer choices. I just left it like that. Plus c. And that comes out to be answer choice C. Yeah, if you anticipated it being like U substitution, really you could have eliminated your answer choices immediately to just C or D. Really, those are the only two that somewhat look like they would come from a U sub where U is X plus 3. And then you got a 50-50 shot when you had to guess, but of course we want much better odds than that. All right, questions on number 4. Not the hardest U sub you'll ever see. Pretty straightforward. 1, 2, 3, 4. B, 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 C. All right, number 5 then. It's 3 over a quadratic trinomial. The derivative of the quadratic is 2x plus 4. Nowhere close in the top. Not going to happen. So it's not a natural log. The next thing you might try to do is factor the denominator. Because if it factors into a binomial squared, then we can bring it to the top. It's going to be a linear inside function. It'll be a power rule. But does x squared plus 4x plus 8 even factor at all? Factors of 8 that add up to 4? No. Okay, so I'm walking you through kind of the sequence of what you'd consider. So if it doesn't factor at all, boy, it'd be nice if it could factor. Can we make it factorable? Yes, so this would involve completing the square by adding a clever form of 0. Good. So here's what it looks like. I pulled the 3 out front. You complete the square on the two variable terms, x squared and 4x. The coefficient of x squared has to be a 1 in order for this to work, and it already is. So one less thing. If it weren't, you'd have to factor it out from both your x squared and x term. All right, so how do we know what to add? Half the linear coefficient squared. What's half of 4? 2. What's 2 squared? 4. So I just added a 4 in the denominator, so I don't change the value. I need to now add the opposite, or subtract the 4. And then the plus 8 that was of no help gets thrown at the back. All right, so now if I group the first 3 terms together, I have created a perfect squared trinomial for myself, and it factors into x plus 2 quantity squared. Then you get the numbers at the back together, negative 4 plus 8, they become a positive 4. So if you do complete the square, it should then always set up an inverse trig. And because there's no radical, if it's going to be anything, it's going to be an arctangent. So u squared must be x plus 2 squared, so u must be x plus 2. What's the derivative of x plus 2? 1. That's exactly what we have in the top. We're not off by anything, so no correction. A squared is 4, so a is 2. So we're ready to go for it. Here we go. 3 goes along for the ride. It's out front. There's no correction to make. Does arctangent have a 1 over a in front? It does. So there's the 1 over 2. Arctangent of u over a, x plus 2 over 2, plus c. And these were in terms of arctangent, so 3 times a half is 3 halves. And you're done. Oh, in the form that we memorized, we have a single function. So this whole thing would be u squared, and this whole thing would be a squared. Yeah. All right. Yeah. All right. So there you go. And in this case, I did put some answer choices that were natural log, some power rules, but 2 of them were inverse trig. So again, if you know anything about test design, if 2 of them are kind of the same variety, they might be that variety. But there was no radical, so it couldn't be an arc sign. All right. Questions on number 5. Let me do a little follow-up here. What if I had just started you out with this? What if I had just given you 3 over x squared plus 4x plus 4? Now 2x plus 4 is still the derivative of the bottom, but it's not in the top. You would now try to factor immediately on your own. And you would see that x squared plus 4x plus 4 actually factors into that, right? We'll get rid of the plus 4. It factors into that. And now, x plus 2 could be the inside function. Its derivative is 1. So when you bring that to the top, it would be to the negative second. Now it would just be a power rule, right? It would be that to the negative first divided by negative 1. All right, but because it didn't factor, we completed the square. Now we have this extra term, which is why it's an arctangent and not just a simple power rule. All right, number 6. On the heels of that rational function, here's another rational function in our integrand. But this one's got lots of stuff in the top, more than just a 3. It's got a quadratic trinomial again. The derivative of the bottom is 2x, nowhere near the top. So this is where you need to be on the high lookout for degrees of your polynomials on the top and bottom. When the degree of the top is the same size or bigger degree in the numerator, the first thing that you do, all other methods get pushed aside, and you do what first? Divide. You do long division. Yeah. So here's what the long division looks like. Numerator is your dividend. Denominator is your divisor. X squared goes into 2x squared. It's the same question as what is 2x squared divided by 1x squared? 2. So then you distribute. And this is where you get the 9 involved. You get a 2x squared plus 18. There's no linear coefficient. So now when you subtract, remember you just changed the terms in the second row here. 2x squared minus 2x squared, that should always be 0. Here it's a bonus that your coefficients canceled out, but we still have an x there. And if you want, you can put an x minus 0 if you want. What is x minus 0? X. Does x squared go into x? Nope. So we're done. So what do we do with this information? We rewrite the original integrand, which I wrote up here again, as parentheses, the quotient 2 plus the remainder x over the original divisor x squared plus 9. Now it's 2 terms, and so we do our analysis kind of all over again. The antiderivative of 2 is pretty easy. It's just 2x. This one here, though, the second one, if you rewrite it in the numerator to the negative first, then x squared plus 9 could be the inside function. Its derivative is 2x. Generates the x off by only a 2. So we got it. So now I'm ready to integrate, so I'll drop the integral in the dx. 2 becomes 2x. Here we have a correction of a half, and the x gets packaged up. And so when your inside function's in the numerator to the negative first, it's natural log of the absolute value plus c. And there's your answer. And I left the absolute values on in the answer choices, but could we get rid of them here if we wanted? Yes, x squared plus 9 is positive. Now, I would not give you an answer choice that was that with the absolute values and the same thing without the absolute values. You'd have one or the other because they are equivalent. What's that? Okay, real quick, just a little add-on here. What if those constants didn't cancel out? What if it were like an 18 minus, for just hypothetical reasons, a 17? Now we'd have a plus 1 there, wouldn't we? Now it would be that over plus 1. Oh, now the derivative of x squared plus 9 is 2x, not x plus 1. So what would we have to do in that second term? You would just split it up. So it's another strategy. Very good. You'd have x over x squared plus 9, which would give you the natural log we just saw. And then you'd have 1 over x squared plus 9, which would then turn into an arctangent. Yeah, good. So, again, a combination of strategies. But this one didn't need that because the constant went away. All right. How are we doing? We're through number 6. 2/3 of the way through the multiple choice. Questions? Comments? In hindsight, they're all kind of what? Not so bad? They're not so bad. Yeah. As long as you knew what to do, there was really not a trick or a gimmick so far required on either of them. All right, number 7. Big F is an integral expression or an integral function, and we're trying to find its derivative, big F prime. This is the second fundamental theorem of calculus, or the fundamental theorem part 2. All right, so to find big F prime, we need to take the derivative of both sides. The derivative of big F, of course, is big F prime. The derivative of the integral, derivative of the integral, that's the second fundamental theorem. So the general procedure, remember, is to plug in your upper limit of integration, x squared, for your variable. There's only one variable, it's t. So it becomes 1 plus x squared quantity cubed. And you can't forget to do this. Then you multiply by the derivative of not what you created, but of simply what you plugged in. What's the derivative of x squared? 2x. Good. Minus, in general, plug in the bottom. It happens to be a number. So you get 1 minus pi cubed under the radical times the derivative of pi, which is 0. So if you have a constant, that term is going to be wiped out, whether it's the first term or the second term. In this case, it's the second term. So your final answer then is 2x times the square root of 1 plus, x squared cubed. When you raise a power to a power, do you add the exponents or multiply? You multiply, because it's x squared times x squared times x squared. So it's x to the 6th. So that's answer choice D. If you did everything right, but you added the exponents, I put a flavor there for you. It's E. If you knew what to do, but you forgot the chain rule, you forgot to multiply by 2x, it was answer choice C. And if you just simply thought it became 1 plus x cubed, then it's answer choice A. So lots of different varieties there. But the answer choice was D. That was correct. Now this one right here was a little bit more difficult than the one on the back on the free response. But more people got this one right than the one on the free response. I don't know if it's because it was the context of the type of question it was or what, but we'll get there. All right. And then number 8. 8 is very similar to what we did a couple times in the notes with sine and cosine. Believe it or not, number 8 was the question on the multiple choice that most students got right. So, yay, way to go, students. If you rewrite both of those that are in condensed exponential form in expanded form, you get tangent of x quantity to the 6th, secant of x quantity squared. If you chose secant of x as the inside function, thinking that it would be a blob squared, the derivative of secant is secant tangent, not tangent to the 6th. So that's the wrong choice. So if you then chose tangent as the inside function, inside blob to the 6th, the derivative of tangent is in fact secant squared, the complete other factor off by nothing. So secant squared gets packaged back up. There's no rider, there's no correction, so we move right on to the rule of integration. Blob to the 6th becomes blob to the 7th, either divided by 7 or times the 7th. And then if you fix that answer, of course, you can put the 7 back in the condensed slot between the n and the x. And the answer choices did have divided by 7, so plus C. So there you go. Kind of a nifty little one. Not as bad maybe as it looks. That's why people got it right for the most part. That's good. If you got it wrong, don't feel bad. You got others right that others got wrong. It wasn't the easiest one, I think. Number 9. I put number 9 there on the very end because I wanted to end on a strong note. I thought I'd give y'all something that was easy. I made it a definite integral, though, so you had to evaluate it. But the antiderivative of tangent was something that we just flat out what? Memorized. And it was something you could even derive if you did the ratio identity, sine over cosine. But what is the antiderivative of tangent? Good. Negative natural log absolute value of cosine. So there's the antiderivative. Negative natural log absolute value of cosine. But now, instead of plus C, we're evaluating it from 0 to 1. So again, the way I do things personally is I leave my constant multiples out front when I'm evaluating, including just a negative. So I have a negative or a -1 beefy brackets. And now I'm focusing on the positive, natural log. I plug in the top, and I get natural log absolute value of cosine of 1 minus, plug in the bottom, natural log cosine of 0. Free response, that's a good place to stop. Notice my negative is out front of the brackets, but it's still a minus in here, because that's the rule, top minus bottom. If you distributed the negative all the way through, your first term would be negative, but the second one would be positive. So you'd have to be very careful with that. But now we need to evaluate it. So let's see, cosine of 0 from the unit circle is 1. So that becomes the natural log of 1. And I drop the absolute values because 1 is positive. Cosine of 1, that's 1 degree or 1 radian? 1 radian, which is in quadrant 1. It's like 57 degrees. I don't know what cosine of 57 something degrees is, but I do know it's positive. So I could drop the absolute values. So that brings me to this line. What is the natural log of 1? 0. So now I get to that line. Anything minus 0 is itself. Notice I am showing every single painfully easy little step. And I'm left with my final answer, negative 1 times the natural log of cosine of 1. And I look, and I look, and I look, and I look, and the answer is not there. But I do see a positive natural log of cosine of 1, and I'm thinking to myself, that must be the same. But that's not right. So if you forgot that the antiderivative was a negative number, and just thought it was positive natural log of the absolute value cosine, you came with positive natural log of cosine of 1, and that was an answer choice, but it's not the right one. So how can we contend with that negative? I mentioned it. When you memorize tangent, I said, you don't have to memorize the other version, but remember, College Board loves to play with logs. Therefore, you have to know how to play with logs. And the negative 1 can go where? As an exponent, yeah. We could bring that negative 1 up as an exponent on the cosine of negative 1. Now, here's where maybe some of y'all got messed up. When you bring the negative 1 up, if you do it hastily, maybe you don't bring it high enough and you bring it kind of on the ground floor instead of the exponent. Now it looks a lot like the natural log of cosine of 1 minus 1, which is answer choice E, as opposed to the natural log of cosine of 1 to the negative first power, which is what it should be. And of course, anything to the negative first power is the same as the reciprocal of that. So the reciprocal of cosine of 1 is 1 over cosine of 1. And then finally, by the identity, 1 over cosine of 1 is the same as secant of 1. So that's one way to do the problem. The other way to do the problem is just to realize from the very beginning that the antiderivative tangent is equivalently the positive natural log of the absolute value of secant. And then you could have plugged it in. But I don't want you to do that. Okay, just remember that numbers that are out in front can become exponents, which then turns it, in this case, to a reciprocal. So, anyway, not as many people got the last one right as I was hoping for when I put it on the test. All right, any questions then on the multiple choice, 1 through 9? Same test tomorrow, everyone makes 100. Okay, which is why we won't have one tomorrow. I want you to think about it, let it soak in. And then next week, maybe, or the week after spring break, maybe another one with different problems, different order. But hopefully you're getting more comfortable with this. All right, then the free response, that was a little more disappointing than the multiple choice. Oh, I told you what it was going to be, and then even mentioned that you might have some stuff from Chapter 3, like local max and mins, but not many people pulled it off. So let's see. We have a graph of little f right there, and it's made up of a bunch of little triangles. So you're going to have to find areas of triangles, 1/2 base times height. Pretty easy. We're on the interval from -4 to 12, and I'm defining big F to be the accumulation starting at 2 up to x on the graph that I gave you. So I even start at the same place like I did in the notes, starting at 2. All right, so if you want to come up here, I highlighted 2. That's the starting value. Part A has 3 different questions. And I gave you 3 instead of just 1 or 2 because I really wanted you to start accumulating lots of points here, because I figured this would be the easiest thing to do, but it didn't turn out that way. The first thing is, if on part A or any part I ask you for more than one answer, is it important to label or distinguish among your answers? Which is which? Yes. A lot of people did that. F of 2 equals, F of 8 equals. But almost as many people did not do that. They just wrote down 3 numbers and then walked away. And if you do that on an exam in the future, whether it's mine or AP, you're not going to get credit for any of them, because the person grading your paper is not going to try to figure out which one is which. So even though they're listed from left to right, if you list answers from left to right without labels, it's not going to be assumed that that's the 3 answers you're given. So make sure you label everything. F of 2, F of 8, F of -4, that's all you got to do. All right, so the function is from 2 to x. So get in the habit, again, on the free response of showing everything. Big F of 2 is the net accumulation from 2 to 2. So the 2 highlighted 2's are the ones that have to match of F of t dt. Now, without even looking at the graph, you can assume that this one's equal to what? 0. We haven't gone anywhere. We haven't accumulated anything. So it's 0. And that's the first check. That was the last and only check some people got on this section. Okay, unfortunately. F of 8, that's going to be the net accumulation from 2 to 8 of f of t dt. Well, now we go to the graph. 2 to 8, 2 to 8. Let's see. Here's 2. 8 is going to be over here. It's half of that second triangle, so I'll draw a vertical line. Remember that if you find the areas of the regions and you write them in the region, then as long as those numbers show up in your calculations, that's enough to indicate your method. You don't even have to show the computations for the area. I did, just so you can see where they're coming from. The first triangle, 1/2 base times height. The base is from 2 to 6. That's 4. The height is 4. So it ends up being 8. But the key is to write 8 in there and circle it. The other one, by symmetry, should be half of 8. Or just compute it. 1/2 base times height. It ends up being 4. So here's where we're using then the areas to help us find the integrals. And we have to use the correct SIGN. We're going from 2 to 8, so that's left to right. That's chronological order. So any region above should be a gain, a positive, and any region below should be a negative, a loss. So it should be a positive 8 and a minus 4. All right, so there it is. 8 minus 4 comes out to be 4. Or leave it as 8 minus 4. That's fine. That's the second check. The next one, f of negative 4, we're going from 2 to negative 4. From 2 to negative 4. By symmetry, you have the exact same areas. Positive 8, positive 4. Calculate them again, it doesn't matter. But what's the noticeable difference here? We're going from 2 to negative 4. That is from right to left. So everything is backwards. So above is now negative and below is now positive. So that should be a negative 8 and a positive 4. A negative 8 and a positive 4, which comes out to be negative 4. And that's the third check. So if you got all three of those, great. If you didn't, I don't know what you were doing. I saw a lot of 12s and negative 12s. I'm not sure where 12 came from. Maybe just adding them together every time instead of doing subtracting. You were finding areas, but then you put a negative 12. I saw a lot of 4s and positive 4s, which means you didn't take into consideration, the direction you were going. So anyway, there's 3 checks out of 9. That's a third of the checks. Then I threw 2 more at you that I thought would be pretty easy, so that at least you'd have 5 out of 9 for sure. I wanted you to find f prime of 0, but I thought, hey, I'm going to make you find f prime of x first and give you points for it, because you'd have to do it anyway. All right, so f prime of x. So I rewrote f up there. Remember, f above, big F, was told to be the integral from 2 to x of little f of t dt. We had one on the front on the multiple choice that dealt with the same thing. The derivative of the integral. The derivative of the integral is fundamental theorem part 2. So right here, I did the exact same general rule. Big F becomes big F prime, and then to evaluate the derivative of the integral, plug in the top for t, and it becomes f of x times the derivative of x with respect to x is 1, minus, plug in the bottom, you get f of 2 times the derivative of 2, which is 0. Now, you didn't have to show that because this is a special case. When you go from a plain old number to a plain old x, the derivative should just be the integrand as a function of x. So what I was looking for is big F prime of x equals little f of x. That was the fourth check. 2 notes. First of all, big F and little f are both f's. Some people were writing them, and I could not tell the difference between an uppercase and a lowercase. That's not good. So make sure when you have 2 different types of f's like this, that there is a clear distinction between the upper and lower case. Because if they look the same, there's no way to grade it. We just have to count it wrong. All right? So my little f's have a little flare on them. My big F, I try to make them kind of blocky in the top left corner. But there's a distinction that's clear between them. The second thing is, at this point, I was looking to give points away. So a lot of people right here put big F prime of x equals little f of t. Is that right? No, it has to be a function of x. But if you have little f of t, I gave you the fourth check. But then I circled it and said something like must be little f of x. But it was the right idea. You knew that the derivative of big F is little f, and that's the name of the function. Just need to work on getting the independent variable the same. Again, the reason it's different up here in f of t dt is so that there's no ambiguity as to what the independent variable is and where and how it affects the value of the integral. All right, so now that you have the derivative, then all you have to do to find big F prime of 0 is plug in the 0 to both of those. So big F prime of 0 turns out to be little f of 0. And if this is the graph of little f, I just want the function value at 0. That's the y-intercept, and it is labeled as 4, and that's the answer, 4. I saw a lot of zeros here as the answer, which is exactly how many checks you got if you put 0. I'm not sure what you were thinking if you put big F prime of 0 is 0. But anyway, it was a common answer. So there was 5 checks out of 9. So only 4 more to go. And if you got 5 out of 9, you were above the average on here, because the average on here was pretty low. Only 3 out of 9. Which, if you remember, as we've looked at just a very few of the actual averages on the actual AP questions, 3 is about average for the average out of 9. So, but I have higher expectations for y'all than the average. All right, so part C, find the x-coordinate only of any local minimum of big F. Local minimum of big F. So here's where it started getting very vague and ambiguous for a lot of students, using a lot of pronouns. First of all, local max and local mins of any function can only occur at what type of x values? Critical values. You have to first claim or find critical values. Critical values of any function are where that function's derivative is 0 or undefined. So I want to know where big F prime, which we already said was little f, equals 0 or is undefined. You got to check for doing that. If you just said big F prime of x equals 0, check. If you said little f of x equals 0, check. It turns out that there are no places where it's undefined. If you look at this graph is equal to 0 at -2, 2, 6, and 10. This graph is never undefined. Its slopes are undefined, but the graph itself is continuous. So of those critical values, the only one that's really of interest is -2. So you could have said big F prime of -2 equals 0, or little f of -2 equals 0, but you had to identify it as a critical value in that sense. And very few people did. So that was the 6th check. Now at the critical value, we want a sign change in the derivative of that function. We're talking about local minimums of f. So we want a sign change in big F prime, or a sign change in little f. Well, if we come up here to -2, little f, which is big F prime, changes from negative to positive. So there's your local min. At 2, big F prime is positive on both sides, so that's neither a max nor a min. At 6, big F prime changes from positive to negative, so that would be a local max of big F. And at 10, little f or big F prime is negative on both sides, so that would be a neither. So -2 is the one we want. So here is the 7th check. Big F of x has a local minimum. Some people put there is a local minimum. There is a pronoun, don't use it. F, big F, has a local minimum at x equals -2. Sometimes that would be a check, but in this case it wasn't a separate check. Since either big F prime of x changes from negative to positive at x equals -2, or since little f of x changes from negative to positive at x equals -2. That's what I was looking for the 7th check. Some people said that, but they just said since little f changes from negative to positive. And again, I begrudgingly gave them a check. But you really need to have this here because you're saying two things. You're saying here's where the local minimum is because that happens to also be the location where the signs of F prime, big F prime change in this fashion. Now, let me tell you what I saw a lot of. A lot of people alluded to this idea, but they just said there's a local minimum at x equals -2 since, and then it got real creative, since the sign changes. The sign of what? Since the graph changes. I gave you a graph, but is that the graph? There could be a graph with a definite article under lock and key in Washington somewhere, and it could be the graph, okay? So that is still, believe it or not, vague, the graph. Since the values, since the slopes of what? Since the sign, okay? All those things, or since it, that's another one, since it changes. What is it? Do not speak ambiguously. You're not going to get credit. You can't get an autograph if you can't catch the guy doing it. All right. So anyway, speak with proper nouns. Go ahead and talk about the function itself. Again, in this case, either big F prime or little f. And then always say it twice. All right, so that, you could have gotten 1 out of 2 checks. And many people got 1 out of 2. Now the last part here, because we're running out of time, does big F have an inflection point at 4? Inflection points can only occur at PIVs, possible inflection values, which is where the second derivative is 0 or undefined. Well, what is the second derivative of big F? Good question. If the first derivative of big F is little f, and the second derivative of big F is little f prime. And if we have the graph of little f prime ends up being the slopes, okay? So where are the slopes of this graph? 0? There are none. Where are the slopes undefined? At every cusp, 0, 4, and 8. Now, I specifically asked you at 4. So you need to identify it as a PIV. So just like before, you have to say something to the effect, either big F double prime of 4 is DNE, little f prime of 4 is DNE, or the slopes of F at 4 are undefined. Something to that effect is the 8th check. You can't just say since it's undefined, or since the slopes are undefined, or since the function is undefined. That doesn't work. And then, of course, we need a sign change in the slopes of F for it to actually be an inflection value. And at 4, the slopes of F change from positive to negative. Or F, little f, changes from increasing to decreasing. Or the sign of F double prime, big F double prime, changes from positive to negative. Something to that effect. Therefore, there is an inflection value at x equals 4. That's the 9th check. But again, a lot of people just use vague terminology there. Something changed signs. I don't know what something is, okay? So you could either, again, say the slopes of F, little f prime, or big F double prime. That was the 9th and final check. So anyway, keep those. Soak up all the information from that test. I'm not sure if we will have another test over this, per se, like the first week back, but it wouldn't be a bad idea. Because this is a really important idea. And I don't want to necessarily move on unless I feel that more people have a firm grasp of it. So anyway, that's it. You have about a minute left before you go to the next period. And if you want to watch this video again, I did record it. And I'm going to put it in the shared folder under Chapter 4. So you can watch it every day over spring break.